And I'm thrilled to have both an incredible panel today, but also all of you who've tuned in, because this is today's topic is a really important one, and it's one that really doesn't often get the thorough airing that it deserves. And we're especially lucky today because to help us understand the topic of automotive grade, what it means and how it's relevant in particular to the world of driving automation, we have 4 different gentlemen with different perspectives from different parts of the industry. And I'm sure between all of them, their experience is really going to help make this concept easy to understand. From Toyota North America, so on the OEM side, we have Derek Caveney. He's an executive engineer with Toyota North America. Derek, welcome. From the tier 1 side, we have from ZF Group, Dr. Reinhard Ernst, Senior Manager for ADAS Validation. Dr. Ernst, welcome.
Hi.
And also from the tier 1 world, we have Dr. Gunnar Juergens. He's the VP and Head of Lidar at Continental. Dr. Juergens, welcome.
Hello, everyone. Good to talk to you.
And last but not least, from the world of component suppliers, in particular LiDAR and well, perception, I guess, sensors, I should say. We have Jordan Greene. He's the co-founder and VP for corporate development at AEye, which is a PAVE member. Jordan, welcome.
Hello. Thank you very much.
So I want to start with kind of the basics here, and because again, I'm guessing most of our attendees here are not from the automotive industry themselves. I think there may be some sort of a sense of what automotive grade might mean, but I think in particular, because we have sort of all the different parts of the supply chain represented here, it would be great to kind of hear each of you explain in the simplest terms possible what automotive grade means and how it applies to the work that you do. So Derek, let's start with you from the OEM perspective, right?
Sure.
You're the final customer for the supply chain, if you will. What is automotive grade? The simplest way to explain that, and in particular, the way that you have to deal with it.
Thanks, Ed, and thank you to PAVE for inviting myself and the other members to this panel today. Really happy to be here. I'm Derek Caveney. I sit in Ann Arbor, Michigan, and of course, Toyota is a really large company, but my particular group focuses on connected and automated technologies and deploying those here in the US. Because we're such a large company, where I sit is really in the integration of the system level, the sensors and the processors and the human experience to provide that final system. And so automotive grade to me, in its simplest terms, and I'm going to kind of steal this from a competitor, is like built tough. And built tough is like how you define tough, right? Tough, in my perspective, is about reliability and robustness. We have to design not only the sensors, but the whole system to almost work in the worst case. And that means that we have to consider, if it's a personally owned vehicle like a Toyota Camry, we have to consider it being operated maybe in Alaska or in the Arizona desert. And when we talk about automation, highway automation or parking automation, whatever you'd like, those exist in both those environments. So we have to be able to provide a service to our customers that is reliable and robust. And that to me is what it means to be built tough or automotive grade.
Yeah, and then the next, so moving to the tier 1, yeah, Dr. Ernst, I'd love to get your perspective from the side of the business that you look at.
Yeah, I fully copy that statement. And I think just imagine that you cannot utilize any, let's say, simplified processors that you are currently using maybe in a mobile phone or something. Yeah, so you will not bet your life on such a device, I guess. Yeah, so that means if you have that in a car that's running, maybe the Toyota is running 20 years or 10 years, yeah, so a very long decade. And then if you go further with, let's say, more intense and more sophisticated functionality, like going towards more autonomous driving, the thing becomes even more problematic. In that term, we must be really rigorous in the way how we get this thing tested. And the thing is a term that's not a standard, but I think it starts very often with a discussion, what is a component in a car? Yeah, so we obviously know about these microcontrollers, but on this microcontroller, there's also a software. Also, the software must be, let's say, in an automotive grade. Yeah, so we can talk about Linux, you can talk about specific AUTOSAR stacks, and so on. Yeah, we know all that stuff. Yeah, and then you also have the safety perspective into that. Yeah, and from my area where I work with, so from my background, I worked almost 14 years in a server environment. So I worked for a big provider for computers, mainframe systems, yeah, and therefore reliability long-term with the mean time between failure of 100 years is key. And now bringing that into automotive perspective, having that kind of computer running in various temperature areas, in the deserts, in the cold, with bumpers, with mud and everything, yeah, and still it needs to be intelligent work, at least to be safe, yeah.
Yeah. Absolutely. And Dr. Juergens, I'm going to skip you for just 1 second so I can go to Jordan and then come right back to you, because I know you two work together, but I want to get the component perspective first. Jordan, as a sensor maker, what is the role that automotive grade has played in your work?
Sure. I mean, I think it's the trickle down effect. I think the requirements as they come in from the OEMs like Toyota to deliver on those level of requirements and then flow through the tier ones ultimately end up hitting the suppliers on all levels. It's the ability to be able to deliver a product as Derek and Dr. Ernst or Dr. Caveney and Dr. Ernst said accurately, influence the reliability in the vehicle and the quality of the vehicle. And so ultimately that's all the way down to the sensor level. So there's different levels of quality and reliability that you expect when you get in a vehicle. If you turn the wheel, your tires better turn. And so there's certain levels of I guess risk assessment or hazard analysis that need to be performed at the lowest levels that ultimately influence the highest levels. And it all comes down to, I mean, the ASIL levels of severity, exposure, controllability, and the ability to actually work within that to understand what you are speccing to. And it's a vastly different world than a lot of the consumer commercial markets. And so we're very lucky, as you accurately stated, to be working with someone like Continental, who has 150 years of doing this and can bring quality products like that to market.
Yeah, and Dr. Juergens, I want to get your perspective on this as well, because obviously Continental does have, as Jordan mentioned, lots of history of doing this work in sort of the traditional automotive aspects, which is where obviously the concept of automotive grade comes from. But now you're applying that also to these new technologies. Can you explain how you're able to draw from that experience in this whole new area?
Well, sure, and thanks for having me. And I'm very happy to speak on this panel, and I think all of the speakers are somehow connected and can add to what everybody's contributing. And just as an example, we of course supply to Toyota, and in my personal responsibility, the Lidar segment, we are proud to be a Lidar partner for Toyota going into SOP this year with a solid state automotive grade product, which is the first in the industry. Conti is probably known as a big tier one for me as a person. I'd like to say that safety and quality has always been part of my DNA in 18 years at Conti, and I was heading R&D actually for passive safety as an example. So dealing with airbags, automotive grade technology for 6 years. I have been responsible for driving functions, so all the functions that make you safe during an emergency situation or keeps you comfortable while cruising on the highway. So responsible for this for 4 years, and now I'm responsible for the Lidar segment in the last 2 years. Just to add, and I can copy everything that was said, I think the automotive market is special in that sense that it's a B2B situation. So a customer like Derek, they know so much about our products that they really know where we can fail, right? And they really go deep. And this relationship, I think, is very crucial for creating the final quality of this product. So it is not a one-time buy where people go into a shop and buy it, right? And read the first page and then throw away the rest of the manual. But we actually, and it's often not understood, even if we agree on a contract, we work 3 to 5 years before a single component is ready for the final requirements in one vehicle, right? So it's a process, and on top of the technical requirements, it is about being able to work together in this process, going through all these stages of testing in our company, but also in the target company. And then it is the organizational capability to get all the learning from the development into changes that improve the product, right? And this is an experience, this is an organizational know-how, which is probably unique for automotive. And this is why automotive grade is such a high standard, which we have to protect and carry forward, especially in the world of autonomous vehicles, where automotive grade directly is connected to safety, right? So coming back to the airbag, this is such an, I think, important product, because it is actually a product that nobody wants, and you never want to see it, right? And you never want to see it in action, but you buy it because you know it is there and it will work only when you need it, yeah? And it will sleep for 10, 15 years. And if it comes to work, the lifetime is only 200 milliseconds, yeah? And then the product is broken. But in this 200 milliseconds, nothing can go wrong. And this is automotive grade. We want this level of functionality, availability, robustness, reliability for everything we do with AV vehicles.
Absolutely. And Derek, I want to talk about the requirements, right? As the OEM, you set the requirements for any given component, and obviously that's tied into the system that you're developing. Talk about what those qualifications might be, and why they're important and how you set them.
Yeah, sure. Let me start with the setting. The setting is often driven by the customers, right? What do our customers want? Where are they going to drive our systems, our vehicles, our AV shuttles, whatever it might be? And that, as Jordan says, trickles down to the different levels of suppliers. Some common requirements that we have for any component is about the way it can handle heat and cold. So, -40 to 140 Fahrenheit, it's common. We consider cycling. If it's a mechanical component, like cycling, how much could a mechanical laser or a mechanical washer for that laser can operate before there might be a failure in the component. Of course, electromechanical robustness. We do a lot of EM chamber testing to make sure that we've shielded all the circuits correctly and we have good robustness to any external fields. Of course, corrosion and intrusion, water intrusion, mud or snow intrusion. These type of requirements that, as I mentioned, like the worst case, you have to consider for a personal vehicle that goes anywhere in North America, perhaps, that has to be able to handle what you literally throw at it, mud or snow or rain. So those are some examples of our requirements. One more, maybe more on the electrical side, is like boot up times. Like it has to come alive really quickly after you IG on. It has to be available for the customer to understand that it's ready to serve you when it's needed. So you'll see a lot of icons on your screen, telltales on your meter as you light up the car. That has to confirm that the systems are ready to go when you want to use them. So those are some examples, Ed.
Yeah. Jordan, I just want to, when you started developing, sensors, I mean, were you aware of all of these kinds of requirements that at the OEM level we're going to require, and sort of how have you sort of gone about, meeting them, and in particular, like with your partnership with Continental?
Yeah, it's a good question. So the interesting thing was that all of our backgrounds were from aerospace defense. So we had a very solid understanding of the rigor of testing needed to get a qualified component to market. Now they're different. There's similarities. There's certain extremes that automotive sees that no other market really sees, and in certain environments that you just have to account for. But we were under the impression that we were going to try and focus on the most robust possible components from automotive qualified vendors, and utilize the value chain in a unique way that would allow us to get to that level of quality. So our goal was always work with the supply chain, which are the tier 2 suppliers, and work with the tier 1s and really broker those relationships and support both of those parties through the entire development cycle, through production and on. And so I think that what we've done and what we've seen is that the business model that we took and the approach that we've taken to go to market with Continental, for example, is second to none in the fact that we can deliver quality products that a customer like Toyota would be able to use in their vehicles, because Continental can guarantee that reliability, and we believe that we're able to support them in that effort, but really an organization such as Continental is second to none in that capability.
Yeah, and Dr. Juergens, I'd love to get your perspective on this as well. I mean, what is your pitch to to companies, that you should partner with them, that they should partner with you in order to sort of get to this automotive grade level?
I think it's pretty straightforward and build upon the experience we have in that industry. Talking about new technology, it's fascinating to look at technical concepts and the limitations of physics. In Lidar, it's what you all can see in adverse weather conditions, in the night, in the distance. You can measure the world the way you cannot with camera and radar. Yeah? And we know it because as we speak, we are producing the 100 millionth radar sensor, for example, for Continental. So there's huge volume and sensor business in our experience. But then you have that technology, and then you talk to a customer like Toyota, and where we focus on is getting this complementary setup in our projects. So technology innovators such as AEye and Jordan himself, they bring about the idea, and we have to then make it work in the context that Toyota is defining. I'll just give you very simple examples. We just talked about space. Yeah, a laser is a very good sensor in space, but in space it would always be working at one certain temperature, for example. Yeah, and that's guaranteed by the system. Yeah, by the conditions that the laser is applied in. But Derek just said 140 degrees Fahrenheit. Which laser has the same performance at 140 degrees Fahrenheit? No laser, right? So we have to deal with this properties of a laser at high temperatures. Next example is in space or wherever you apply a lidar, you look through glass, you have a perfect optical vision. But your car tomorrow, you go into a washing
car wash.
Sorry for my German. A car wash facility where automatic spray, shampoo, and mechanical cleaning faces your Lidar glass. And I bet you 99% of the lidars that worked yesterday do not work after that treatment, right? That's different. So bringing technology, high tech, into this everyday 15 years environment requires certain expertise. So put the competences from the idea into this experience on automotive grade together, then you can build a good product.
Absolutely. And Dr. Ernst, Jordan had sort of mentioned earlier, like ASIL levels, and we talked a little bit about the safety, connection of automotive grade. But can you talk about a little bit more about functional safety? This is something that we've talked about a bit on some of our past panels, but sort of how does automotive grade play into sort of this broader functional safety assessment and work that you do?
Yeah, you need to imagine. So if we have a car with the high sophisticated sensors that we just heard, like the LiDAR sensor and also the radar sensors and the camera. So this is more the business I'm working with, yeah, I'm dealing with. And for sure, you have functionality behind that. You not building in a sensor just for it to be there. So it has a reason, yeah, and therefore has comfort reasons. Like if we have an ACC, it means automatic cruise control. That means it keeps your distance and your speed. You rely on this, that this functionality is really braking if the car in front of you is braking. Yeah, and also if you have, let's say, a certain emergency effect that an automatic brake is to be triggered. I know that Toyota has a lot of history of that in terms of introducing that into the market, very successful. And So this is a certain level of safety that you need to reach, and therefore you have requirements that you specify what kind of safety relevant functionality you expect and how the system should work. And this you can rate in certain grades and how important it is in terms of saving your life, for instance, yeah, and also having functionality that are more or less comfort, not related to it. We call it QM. And then you have the ISO level A to D. And therefore, these requirements are being interlocked usually also with the customer in order to understand the criticality, and there's certain norms. I don't think we need to dig into that too deep, yeah, where it's been describing what needs to be done if a certain functionality needs to be secured or need to be safety relevant, being tested. And therefore, you also need to work out your test environment, because we talked about the sensors itself, but at the end you need to ensure that's been qualified. Yeah. Because as we just heard also earlier, you cannot just plug and play. I mean, you have a Lidar sensor, you have a camera, works perfectly in your environment, and then you bring it into a different environment, a different car, in different positions, and it behaves totally different. Yeah. Therefore, you need to ensure that you have equipment capable to ensure that this has been tested. And it's not just that you jump into a car, drive around and see if it's working. It's really a stepwise approach. We working with the so-called V model. Maybe you all know about this. So that means you start with the software, that you need to start with your units and with your components, build it up, integrate it, because of all of these system of systems is being built out from software up to individual hardware with software, and then the overall system. Yeah. And with that said, all these levels, these steps, yeah, they have specific test environments that need to be considered. Yeah, and the safety functionality to be ensured with your environment, this is directly implying that your test equipment and the test concept is working. And at the end, you need to have a whole chain. That's a holistic part, that you ensure that, for instance, the LiDAR system is working, the camera system is working, then it's the fusion of all that, and the surrounding model is working, so that you have more advanced functionality going to more automotive driving. Yeah. So it was a long story, sorry, but I tried to make it simple. So as Mr. Einstein said in the past, make it as simple as possible, but not simpler. Yeah. So.
Yeah. And Jordan, can you describe sort of that process of taking the sensor through? I mean, we were talking about 3 to 5 years. I mean, what all is going on in that period? Is it testing, validating, iterating the design itself? What does that working process look like?
Yeah, it's all the above. I mean, there's a lot of work that's done in the design and the industrialization of the design, and actually trying to work through the iterations to get to the appropriate design before you freeze the design ultimately. And when you freeze the design, then you have to go through the field operation testing, and it's an extended process where really what you're doing is it's an elongated version of design validation and product validation, right? DV, PV, and ultimately that extended process, which in automotive gets broken down into multiple stages of samples. Your A sample is your pre-DV units, your B sample are your DV units, your C sample are further DV units, and ultimately you get to a production part approval process submission, which is the final stage of that. And that's ultimately that really elongated process that gets you to that level of quality or that level of reliability that you know that it's going to work in all conditions, in all environments, anywhere you drive, in the most extreme desert environments when the sun is blazing and you're in the middle of Palm Desert or Death Valley. It's gonna have to work in those conditions. And so that's why it takes so long. It's because you're testing for every variance, every extreme, and ultimately when you finally submit the PPAP submission, you know that this is a robust product, and the real takeaway is that it's going to be rock solid reliability, and the life expectancy is going to be automotive life expectancy, 15 plus years, 25 years, whatever the requirements are that flow through.
Yeah, and Dr. Juergens, can you talk a little about how sort of when you get into automated driving, like how much tougher do those like the requirements then become? I mean, as you say, safety is sort of important to every part of the vehicle, but when you start to talk about something like a sensor, then obviously, you know, it's even more important, right?
I think on the first line, I think a sensor for non-AV applications has to be as tough as for AV applications as well, right? So you want to be as good as possible, as tough as possible, and you want to meet the conditions worldwide, not in one country, not in one region, not one OEM, but it should be working for everybody, everywhere, all the time. But then there is one big difference to AV, and this is the functional part of the robustness, yeah? Because when you have a driver in a car and something does not work for whatever reason, the human is pretty good in reacting and still, you know, getting things right. But in an AV, this fallback level of a human driver is just not there anymore. So it means above all what has been said before, in AV, the functional automotive grade reliability must be higher. So we talk about a statistical value of failure over lifetime. And this is the big difference. So if you talk about different testing, it's not about temperature cycles and all of this, but it's the functional test over lifetime. This is what is different. So what Reinhard said, for example, if we talk about a vehicle test on the functions, yeah, be it braking function or steering function, whatever, for AV, the testing
I think we lost Dr. Juergens briefly, but we're just about out of time anyway. Are you back? Okay. We do sometimes have some technical challenges here, but you know, we'll go ahead and wrap this up here. There's a lot more to this that we can discuss, and in fact, we will be jumping over to Clubhouse immediately after this. So if you'd like to continue the conversation there, you know, we can absolutely explore some of the topics that were brought here today in a little bit more detail. So you know, look for us. You can go to on Twitter at PAVE campaign. The link to that will be there. I think it might be in the chat as well. But I wanted to thank all of our guests for helping us understand this really complex but also extremely important topic today. Derek Caveney from Toyota Motor North America, thank you so much.
Welcome.
From ZF, Dr. Reinhard, Ernst, thank you so much for being here.
Welcome.
From AEye, Greene. Jordan, thanks so much.
Thank you very much.
And from Continental, Dr. Gunnar Juergens, thank you so much.
Thanks for having me.
And like I said, we will be jumping over to Clubhouse in about 5 minutes. So if you'd like to continue the conversation there, if you have questions that we did not address here, you know, come show up, ask your questions. We will continue to discuss this topic because there's a lot more to discuss. But for now, thank you so much for tuning into another of PAVE's weekly virtual panels, and we will see you next time.
Thanks.
Thanks, everyone.
Good discussion.
Goodbye.
Bye-bye.